Welcome to Automata Theory lecture series. In this lecture, we are gonna see how we minimize on existing DFA, which we eventually get after converting NFA to DFA. So what we do in minimization as we can say that there for the same language we can have more than one DFA. So it is very natural that this more than one DFA all these DFAs are for the same language may be equivalent. So what is the difference between such DFAs are mainly some of the DFA will have more states than actually needed. So we have to minimize those states, and the minimized DFA will be called optimized DFA. So the key factor for minimization of any DFA is to find distinguishable or indistinguishable states. So this is a formal definition how we understand the two states are distinguishable or indistinguishable. For this here we see that if we start for the same string from two different states and reach to the final state, suppose here P and Q, so taking W for the both set we are reaching to the final state, one of the final states. So then we can say that P and Q are indistinguishable. But if it's not reached by any of this path, then we could definitely say that the P and Q is distinguishable state. For this example, we can see that for the state Q0, Q1, for taking any of these string 1 or 0, we reach to the final state Q2. So in this case, according to the definition, we can say that Q0 and Q1 is indistinguishable states. So we can merge these two states to get a single state and get an optimal DFA for that. So this is in previous lecture we have already shown that how to convert NFA and to DFA. This is the example used there, and the corresponding DFA which were obtained for this NFA. So in this lecture we are gonna optimize this DFA. Basically there are two types of method we are gonna use for this minimization. One is partition table, another is merger table. These are initial formal steps of how you're gonna use partition table for state minimization. In this method, we initially divide all states of this DFA into two partitions, which is called initial partition, where one partition contains the non-final states and another partition contains the final states, and further steps are iterated as we go along to check whether any two states of a particular partition whether it is distinguishable or indistinguishable, using the method we previously shown here this way. So after getting all the partition, if any two state, more than one state remains in the same partition, then those states are called indistinguishable states, and we merge those states to get an optimized state. For example, this was the DFA obtained for the example NFA, and this is the transition table, and this is the corresponding DFA. So according to our steps of partition table, we initially divided it non-final and final. This is the initial partition table. Then we check whether this pair A and F are distinguishable or indistinguishable. You can see here that from A, upon taking 0, we reach to B, and 1 to C. And for F, we taking 1, it goes to F. At 0, it goes to 5. So it can never happen that two states reach to the final state taking the same string. So A and F is distinguishable state. So we parted it here, divided into two partitions. Now in this partition, this is a partition of final states. Check whether B and D are distinguishable or indistinguishable. So you can see here B taking 0, it goes to D, and take B taking 1 goes to E. For the state D, taking 1 goes to D, and for 1 it goes to E. So you can see that for both B and D, it reach to the same state, final state E. Okay, D or E. So we can club it to the single partition. For the same reasoning, C and E, we check for C and E also. But C taking 0 and goes to F, and E taking 0 and F. So these two states goes to the same state F. So C and E are clubbed into the same partition. So this it is a final partition we are obtained. We can see A and F are a different partition, B and D same, and C and E. So B and D are merged together, and C and E also merged together to get an optimized partition. Using these modified partition states, we obtain the modified transition table. Okay, it is just obtained by replacing D with B and C with E with C. We get final partition table, and this is a final optimized DFA for the DFA here. So this is the partition table method. The next method we will see how we use merger table for the again we use the same transition table and DFA. So the main approach here, we have to create a table where we use n-1 columns. So there are five states A to F. So we have taken here only A, B, C, D, E, F, E up to E. So in this direction we start with B up to F. Okay, it is written as it here. So to avoid any transition like A, B, B, something like that. So the initial table filled with we cross any cell which are combination of final and non-final. So here A, E, D, C are all be combination of final, non-final. And for the same reasoning, we can say that F, B, F, C, F, D, and F, E all are final, non-final states. So we say that these all cells are distinguishable states. Distinguishable sets of combination. Next, we check whether A and F are distinguishable or indistinguishable. So for start with transition from A. So you can see there for A, for taking 0, it goes to B, and F taking 0, it goes to 5. Okay, and for A taking 1, it goes to C, and F taking 1 goes to F. CF. So CF, already we have proved that CF in the previous first table, the CF is distinguishable state. So we mark here AF is also distinguishable state. Now check the pair of state E and B. So we have to check the transition from both E and B. So from E taking 0, it goes to F, and from B taking 0 goes to D. So DF is already distinguishable state, so we mark it here as a distinguishable state. Next, we check the pair of state B and D. Now we can see that we have already seen that for the partition table case, B, D are indistinguishable state, because for B taking 0 and D taking 0 goes to D, B taking 1 goes to E, and D taking goes to E. So we get the same transition state from B and D. So we put a tick mark here to mark it as a indistinguishable state. For the next we check whether B and C are distinguishable or not. For taking 0 from B, we go to D, and taking 0 from C to go to F. So DF is already distinguishable set, so we mark it distinguishable. Now next we check C and D. From D taking 0 it goes to D, and from C taking 0 goes to F. DF is also distinguishable, so we mark it as a distinguishable state. Now we check for C and E. From E taking 0 1 goes to F, from C taking 0 goes to F, and so we mark it as a indistinguishable state. If now check CE, now check D and E. From D 0 goes to D, D 0 goes to E taking 0 goes to F, and from taking 0 D. So DF already distinguishable states, you mark it cross. So after filling all the cells in the merger table, the states having tick mark are called the indistinguishable state, and these all states, like here D is equivalent to B, and C is equivalent to E. Okay. And similarly, as we have got in the partition table case, the transition table here, replacing all B and C, B and D and C and E, finally we get the same optimized DFA. Thank you.